Hello everyone, my name is Zach Dai from Brock University Goodman School, and in this video I will show you how to use Excel for the data analytics, especially for the pre-processing and the data exploration. So today we will talk about two parts. One is for data cleaning, another one is data exploration. For the data cleaning, we will talk about the noise, missing value, and an outlier. Discretization, binarization, feature engineering, and normalization. And the data exploration, we will introduce the tool of the pivot table and the 3D map to show you how to explain your data to your clients in the real business world. Before we begin, I want to introduce our data here. So this data is coming from the Namara website. It's about the Canadian COVID-19 tracker dataset. It tracks all the COVID cases in Canada from the beginning to May the 2nd, 2020. I have modified this data for the machine learning and the course teaching purpose. So some data are modified because we have too many missing data in the original dataset. So this dataset is pre-filled. So I make this data easier for you guys to use for the data analysis learning purpose. And if you want, you can go to the website to download the original dataset. Also, if you want to do further research, you should also go back to the original data to do your job. And to get the data, you can either go to Sakai and go to our class folder to download the file, CSV file. And also, if you are unable to log in Sakai, you can also go to my GitHub link. Just click this link. It will download automatically. Okay, once you get the data, let's take a look about the data. So this is the data, how it looks like. You can see we have 57,369 records and 11 columns. So I create this table for the metadata. So now you guys should know what is the metadata. But here I didn't put the data type here. For now, I think for this course, this explanation is good enough for your understanding. So we have rent, which you don't need to worry about it, because I use this column to generate the information for the age, gender, and the death rate. Also, the case ID. Case ID is the ID from the Canadian government. They mark each case by the sequence of the appearance of the case. And the province, where does the patient lives? Also the city. The age is the age of the patient and the reporting time. And here because the original data have too many missing value there, so I have pre-filled some of the value to help you get a better understanding about the data. I don't want you guys to struggling at the very beginning to see why there's too many missing. But notice that in the real business world, we have to deal with the missing data, outliers, and noise every time. Don't expect your data in the future will like some cases in the class. They are totally different. So be prepared for that. If you want to choose business analyst or data analyst in your future career, you should know how to do it and you should love to do it. If you don't want to do it, just want to do modeling, I think it's impossible for you to do that in the business world. Okay. We also have the gender, also modified it, and the travel history, which country or region the patient traveled before, and the confirm or preceptive, sorry, whether the case is confirmed or perceptive. And the source is where the data is found, what the case is reported. And the date is the reporting time for the case. And death is till May 2nd, 2020, whether this case dead or not. Also modified. But this modified is maximum restore the distribution from the data. We have two data files from original data. I combine them into one, but they don't have such thing as primary key. Even the case ID for the death table, we only have 9 rows with the correct case ID. Others only have the provincial case ID. I didn't find the provincial ID in the main case table, so I use some statistic way to fill this, to combine those two tables together here. Okay. Now, knowing the data we have, now we have to talk about the noise, missing value, and outliers. So first thing is they are bad inputs or extreme values. Can you find them in the data set? Because in the class, Professor Shuai has already explained what are those concepts. And here we want to do that in the data. Can you find them? So let's look at the data. We have 11 columns. Right. I will give you 5 minutes to try to find some missing value, outliers, and the noise. Can you find the difference between those? Okay, let's come back. First, we ignore the rand because I mentioned it's just for my data modification use. Don't worry about that. And a case ID, in most scenario, we want to use the ID as the input for the machine learning, as the ID is the unique identifier for each row, which means once you get the ID, you know exactly what is case it is. So you will get 100% correct result, but means nothing, right? So for example, if we talk about we want to do a model in a class, I will say like Jim. Let's assume we have a student called Jim. If I know the student name is Jim, and I will predict he will pass this course. So this is the model. If you use something like this, you will get nothing useful. So no one will buy your model, right? No one will trust your model because if I know the name, I also know who he is, right? But some student may say, how about the future results? Right? That's another story. But here, normally we will say the model is like this. If you are a female in the class, you have 80% to pass this course. And if you are male, you may have 70% to pass this course, right? That's just an example. No discrimination for the genders. Also, we can see from the province, this is a good attribute which provides you a very good geographic information about this data. We have different options here. The easiest way in Excel to look at the options is just select header and go to data panel, use the filter. Once you get the filter, you can click the arrow here. Then you can drag up and down to see what options we have. If you want to expand that, you can also expand that. You can see here we have all the regions from Canada, and we also have another option for the people outside of Canada. And those are correct. We can also check the one without region here. So which means we have 13 records in this section. You should think about whether we should keep them or not. Sometimes this part is very tricky because you cannot just say some option should be noise or some is not. It really depends on your purpose of study. For here, we have 13 records out of 57,000. So for me, either we remove them or not would not be a huge problem. But if you remove them, you will miss an important part of the dataset, which is people not inside Canada. But if we don't remove them, this part is too small. It's very hard to give you enough information to make your model if you want to do the classification model for this dataset. Okay, for now, just let's leave it here. Okay, the city columns. The city columns also give you the cities. But we can see there's some problem here, right? We have some spelling error, like encoding issue. Here is the Latin 1 and the Unicode or the UTF-8 here. We can also see some same city has different names here, right? Another problem for this column is you have too many options. When you have too many options, you also need to think about whether we should include that in our model. Just like the IDs. Why we cannot use ID? I mentioned it's prime key, but another reason is it's too detailed information about the records. When you do that, it's like something we will call that overlanding in latest chapters. If you use this column here, it will provide, for example, some city only have one person. If you know that city, you know who he or she is. So you will know what situation, right? So here, because it has too many options here, I will show you later how to count them. You need to think carefully about this. If you still want to use it, you have to clean all those misspelling here, right? In our project, the auto insurance data, which has 110,000 rows here, and some columns also has the same issue like a comic, some misspelling. If you want to use that column, you have to fix that. For the time reason, I won't fix the data from here. So just let you know you should do that. Okay. So for now, because I don't have the time to fix the city, so I won't use the city in this class demo. And the age. Again, age is number, right? You can find the problem here. So we have non-numerical data here, like adults between 30 and 70, pending teens, and 20. So you also will notice we have 180, 200, 999, which doesn't make sense to me because this one is age. I don't think anyone can live that long. They may have some like 100, but 180, 200, 999 may be some problem. So you need to make a decision how to deal with this. But before we look at other columns, this is a very good example here. For example, like which of those are missing value. Okay, so the pending here, which means we for some reason we don't know yet. We didn't ask the patient or we don't have the data. So this one actually should be the missing value. You should treat them as a blank. Right? If we have both blank and pending, you should treat them as the same. But in some case, they might be different. But here, it's the same meaning as the missing value. No information here. Okay, let's see the 999, right? And 180. Because we don't have some number like 120 or something. If we have 120, even the 100, depends on how many people located in that zone. It might be the outliers. So the outliers means what? It means you have some people that looks different from others, but the number is reasonable. For example, let's say, we can say 100 is an outlier. It's an outlier. So why is that? And 999 is not. 999 is for me is kind of typo or missing value. In my opinion, it's like a missing value because 999 is like a default value or some value by default set by the system. So shouldn't use that number in any way. So the difference between those two, 100 is a good number in a zone, but just too high. And 999 is a number, but it doesn't follow into the range. So we can say it's a noise. It's a noise, right? And if you're still struggling with this concept, let's do another example first. Let's say that between 30 and 70. This one is a noise. It gives you some information. This person is between 30 and 70s, mid 70s. So it's from 30 to 75. No less than 30, no more than 75, right? So, but the problem is we need some number here. It's not a number. It's not the format what we like. So it's a noise. You can say this one is noise, right? The teens, another noise, and the 20, the same, right? You can say those numbers, those options, you should treat them as noise. And what else we have? 180 and 200. Those two numbers are beyond the human life expectancies. So why is that, right? You need to think about it. Why is that? Why is 180 or why is 200? For me, I would think those number is a typo, right? It's typo. You can think maybe someone want to type 18 and add a 0 behind, and 200, right? The same 20, add another 0 behind. So you can make a decision whether you fix it or not. Also, we need to check how many of those we have, right? That's another issue of list 0, right? If anyone can tell me whether this one is outlier or a noise or missing value, right? So when we take care about 0, we should be very carefully about that because by default in some software and some type of data, if you're missing some columns, some cells, they will set it to 0 by default. So we should look at this one. Let's check. Let's check. How many zeros we have? Okay, only one. Only one. So in this case, it's hard to know because for me, I would guess it's not a default one because we have pending here, and this is the only one. How many pendings we have? See, we have 8 pendings here. So pending is the default one set by the age. So it's less likely that the 0 is missing value. So what does this mean? Okay, the answer is this one is a newborn baby. If you read the news, you will notice this case, and this is a real case, right? The original data says newborn, so I change it to 0 here. Okay, so this is another one, and that's only one case here. So if we do modeling, this one should be treated as an outlier, because if you have only one case out of 57,000, it won't give you any information. But if you do research, you should take it aside. So be careful of the category of types of bad data. When we say it's outlier, doesn't mean you want to delete them. Right? Even you delete them, doesn't mean we don't use them. We can remove them from the modeling, but we should keep them for the research purpose. You want to do research, we can say aside of model, we have like a string paper with 100 years old and one newborn baby, right? So think about this. But for the modeling, again, for the modeling, you can treat them as outlier. Okay, so this is the case for the problems. And the gender, right? We have 3 options: F female, M male, and pending. Right? Pending should be the blanks. And traveling, right? Where does the people travel to? We will look at it later. Okay, for now, let's just come back to our topics. Yeah. So now we know we have some bad records in the data. So we have some ways to find those problems. And there's a hint that the outlier only exists in interval and ratio data. It won't be nominal data. Right? We cannot say the nominal is outlier. Maybe you can say that it's noise, right? If it's only one case. So in Excel, we have some tools like a box plot. First, let's try the box plot on the age. So the age is the best case in this class. Let's select column of age. You can either do the E, but the best way is select the used cells. The way is hold your Control, hold your Shift, and down. First is click on the age, the first cell. Control, hold, Shift, hold, down. You get this whole column selected. Then we go to the Insert. Find the chart. You can find the bar chart from here. Box plot. We're not doing the bar chart. Okay, now we get our data, but this data didn't show the 180 and the 999 because the frequency for those are too small. Right, we can see the box plot only stopped at like 99 years old, and the bottom is like 16. Right, the mean is here about 83. Most of them are senior people. You can see the quantile 1, quantile 2, quantile 3, right? In those is the main body. But we cannot find, notice that sometimes we can find, sometimes we cannot find the outlier from here. So we believe this range still within our analysis target. Well, 0 is not here neither. So this is the bar chart. And we can also do the histogram. With the same way, insert, you can find a histogram directly from the panel. Let's do it. Histogram. Right. I think most of you know how to deal with this data. And let's just tell you the way to find it. You should do more exploration to figure out how to change the setting. Let's try one, and you need to do more stuff by yourself. Right? There's a lot of resource online. You can learn from the blogs and YouTube as well, like this video. We can change the number of bins. Right? 12, 100. Right? This one is a little bit tricky, so we should carefully choose the bins to show your graphs. Right? With different range of bins, you will get different result. And we will explain another example for this in SaaS Enterprise Miner in the next chapter. But before that, I just want to know what kind of tool you can check your data. If we look at this data, the major body is from the 80 to the 100 years old. So this is main body, and it's another section. You have some options here. One is cut data set into two parts. One is for the senior ones. Another one is for the younger ones. You know, younger is like 70, 79, right? But this one also depends on the correlation or your purpose of your target data. Okay. And the filter, we show that. Scatter plot, I don't want to show that here. It's not the best data for the scatter plot. You need two axes to see the data. And the pivot table, we will show that later at the very end of this class. And the data analysis add-on, which is statistic. And the problem for this one is you need to clean the data first, which means it only do for the numeric data. For example, let's try this one. Try this age. Let's go to the data analysis. And we can find this descriptive statistics. Okay, and choose your input range. Let's go Control, hold your Control and up arrow to the top, Control Shift and down to select all the cells in this column. Output range is the place where you want to output. Let's first click the input box here and click cell. Let's go to the top, Control up arrow. Another way is we can type here to change the cells or for the current use cell. But here just let's do, or you can type here and select summary statistics. Okay. It will say input range contains no numeric data, right? So we see that we have 30 to 75. So we have to clean that first. So let's do this job because later we still want to use this column for some demo. So we select with 180, 200, 999, add out between all those. Oh, sorry, before we need to get the mean. Let's use the easiest way to fill this data. Let's do the average. Okay, the average, the mean is 50 string years old. Let's use 50 string as default value to fill those bad records. You have some other options, like you can calculate the mean by the province, also by the gender. You can do different ways, but here we just want to do a quickly show here. Let's see, to fill. But in some cases, you cannot just use the mean. For example, if it already says between something, you can do that, right? We have those data. So for the 1999 pendings, those missing value, we can say 53. You can select the area and type 53, type the value you want to type, hold Control and Enter to fill all the cells that you've selected. Teens, let's make it 18. Between these, we can say those are 53. And the 20, let's say 15. 3, 20, 15, 18. Some students will ask, can you do this? The answer is yes, because if we want to do this, we don't care about the, remember when we do the model, we don't care about the details too much. We care the detail, but not that too much. We care the main trend from the data. And you can see how many missing value here. It's only about 30 or 40 columns wise, it's not showing here. 30 or 40 records here, so we can safely just change them, fill them. Or you can even just delete those rows, right? To see that. Let's go back. We can do the descriptive statistics again. Okay, we don't have to change the selection here. This column looks fine to me. Let's go. Okay. Contents. Oh, we have the label in the first row, so the age is not a number, so we need to select this one. Okay, it gives you the information about this column. You can also, if you have multiple column with numbers, you can do that in one time, select more. Just the mean is 53, right? We fill the data, but it didn't change the mean. I think if you fill other data here, still won't change. The standard error is very low here, 0.07. The median is 53, the mode is 55, and the standard deviation, right? So 18. Right? We have a 3 sigma above and below, but remember in that case it's normal distribution. We see the data is not normal distributed. We'll talk about how to fix this problem in the next section. Okay, so the maximum now becomes to 100, right? Because we've already deleted the 999. If we don't delete the 999, this one should be 999. Okay, the minimum is 0. That's a problem. That's not a problem here. But we can leave it for now for this part. So the decision always made by you rather than data itself. So many students just ask me, do you have a good way to clean the data, to fill the data, or to remove the data? The answer is no, I don't have. You have to look at your purpose and look at your result to see what you have. Okay, so this is another tool you can use in Excel. Okay, you can think about why outlier occur, right? Why do you care? Right? Also for the missing value and noise, why do they come from, right? How do we treat with them? So once we get them, there are several options. One is the easiest way with delete a row, right? If you delete one row, we miss one record. If you have a large data set like us, we have 57,000 rows. You can delete like 10 rows, 20 rows, doesn't matter too much for the whole pattern. Delete the column. If you have a limited records, you don't want to lose data records. For example, we only have a sample with 50 records. You don't want to delete 5 records at 10%. So another option is you can delete a column if that column has a problem. Or you can fill the column with some knowledge, like we see that and training with a given value, or we can use a mode, use mean, use median, or other techniques like a decision tree for the next chapter. Also, even for the mean, mode, and median, we can do that. I call it global mean or the local mean. What does this mean? If you look at the whole thing, we get a mean here. But if you make a filter on, for example, like Alberta, the mean may change. It's lower, 52, than the global mean, 53. You can make this. Also, you can add like a female here. Female, right? It's 53, and the male should be 54 or 51 something. 51. So you can use this information as a better estimate about your missing values. And let's talk about why sometimes you need delete the whole column. Let's use the city as an example. Now let's use the travel history as an example. The easiest way to do that is just create a pivot table here. Let's select the whole table here. Hold your Control, hold your Shift, right arrow, and down. You get this table selected. And go to the Insert panel. The first option is Pivot Table. Go to here. And just choose a new worksheet. In most scenarios, I will use this one because it's easier for us to play with the data. And we can see the city here. So in the pivot table, you have some option like filter, row, columns, and values. That's the most important concept. So first, let's look at the city. The travel history. Let's put that into rows. If you put that into rows, it gives you the unique options here. And if you put that in columns, we'll give you in the title. So here we want that in the rows. And we want the number of the case here. So for here, you can just pick any the attribute to here. But the best way is to pick one with not blank, without blank. The safest way is to use the ID, but ID has a problem, it's a number, so by default it's asking for sum. We want to change that. You can do here, click on the sum of the case ID, change the value for count. It shows the count. And we can also right click here, right click in the any place with the result values, and show value as the percentage of grand total or the column total. Now you can see the whole thing is 100%, but the pending here is 99.32%. If this is the case, I will say this column is useless because as most of them are missing. We cannot use this column for the model. We can use them for detail checking, right? We can use them for detail checking, like some people will say we can track the date with the place they coming from, right? You see what's the effect. We'll say something interesting, but I want to show it here. You can play with that yourself. But in the data modeling, this is a big problem. If a data is missing more than, let's say, 70% or 80%, the best way is just ignore this column. I mean, And delete the column doesn't mean you should just delete that, because you know the data is valuable, data is money, right? You cannot just delete that. Just don't use that in the model. So we can see here. We can mark them, right? Don't use them. The same thing for the city. You can play with that yourself, depending it's too many. But also you can make another option, just to put the ones with data and put the pending aside to do different model to see what we can see, right? Okay, let's come back. Okay, which approach will you use and why? I've explained that. Maybe you have different options. It's very personal, like different data analytics has different preference. Right? My preference may be different from Professor Yashai, right? And from Professor Ayanso or other my colleagues. They may all different, but you should build a way. To learn this, you need the experience. That's why the experience in data analysis is valuable. Okay, let's come to the next topic. Okay, once we can clean the data, just remove the missing value, outliers, and noise. We get analyzable data here. And we also have another issue is the discretization and binarization. Why we need that? Because the curves of dimension you've learned from the chapter, the theory topic today, and we want to reduce dimension. When we do some model like decision tree, it treats the numeric data as a different dimension. It will consume a large computation power. Though for nowadays, most computer has enough capacity to do that, but still probably if you have too many columns, too many data, you will still have problems. So that is why we want to do this. And this process is also very tricky. Every time once it's tricky is you just need to practice to get some knowledge and experience to do that. You can use the Excel functions or pivot table to do that. I will show both ways. Yeah. So let's still use the age as an example here. You can do several ways to make a bins for your data. First one is equal width, which means same gaps, like 0 to 10, 10 to 20, 20 to 30, right? Or you can do like a 10 to 50, 50 to 100, right? Or equal depth, same frequency. I want, if we look at the histogram, the bar chart. If we put the equal depth bins here, we want the bar chart has same height, right? Same height, which means you get the same size of the data. Sometimes it's important to get the same size. If it's a target value, it's better to do that. So you want to do some adjustment for the unbalanced data. And by official rules, right? If we have some official instruction for how to make the bins, like number of employees in the company, right? We have the North American way, we have a Canadian way, we have a US way. You can look at the website, government website to see how they do the binarization. The discretization. You can do the same way, right? And you just make a mark. Why do you do that? From where is your resource? And you can do by decision tree mentioned in the next chapter. You can use decision tree to find the best cut with the interactive decision tree in a SaaS enterprise manner and encoding, right? So let's do the equal width. This is the formula I've already done for this data set. You can use a similar way. Let's explain that how to do it. So we have this age. Let's say we want to make some bins for the age. Here we want to make a group for the ages. Let's add a column here. So we put the age group here. Age group. And we make a plan for the bins. We can say and groups. We can say 10 to 0 to 20, right? 20 to 40, 40 to 60, and 60 to 80, 80 to 100, and 100 and above. It's better to make the second number one less to make it processing, right? It's 40 to 59, 79. Right. The bins would be from the lower bound would be 0, 20, 40, 60, 80, and 100. Right? It's the lower bounds. It's the lower bound. Let's use the VLOOKUP to do this function. VLOOKUP. I know some of you guys know the VLOOKUP, but some doesn't know exactly what it's doing. It's a very powerful function. We just look up the age from this table, and remember to put the absolute reference for the table. We want the second column. And the last parameter is the tricky here. We want to use the true, because we won't have the exact same number of 5 in the bins. So we want the nearest lower one here. True or 1. Right. So it gives you the group reference. Right. And in my note, there's another way to do that with a lookup. I think when you read that, right, from the cut points here, you get the names here. You can also do it from another way. And if you don't know Excel, well, you should do this way first. Do this way first. And remember, if you want to keep this one, in the case later we want to delete those bins, you should copy and paste as value here. Okay, now we have our groups. For this one is called equal widths, right? They have same differences, 20 years each. Let's do another way for the equal depths. Okay, let's think about this problem. To do the equal depths, what do you want to do? We want to make a plan. Let's say we want 10 groups, right? We want 10 groups. So we have 57,361 cases here. So each group will have the count age this number divided by 10. So we will have cases, groups, right, sites. So which means you will have the size here. We from 0 to the 100 or 110 something. We want every 5,736 records be a group. So this actual thing what we're doing is here just rank, sort the smallest to the largest, and we pick the every time pick 5,736. Well, we can easily do that. We don't have to count here, right? If you count here, it's very boring. We can use the rank, right? Rank takes two parameters. First one is the number. Second one is the range. Let's Control Shift down to select that. And remember, every time you use a range, you need the absolute reference here. Okay. So it's the lowest to the highest. So it's highest to the lowest. Let's go down. It will decrease. Give some time here. So we can see the rank is listed down here. You don't have to sort if you use the rank. And I think this one takes some memory. Let's copy this to value here. Put the depth to the second. This one is the rank. Right. Now what we want to do is we want to cut them into 10. So the easiest way would be just do the rank divided by 10. Sorry, divided by 57,360. Right. Just divided by this number. But when you drag it down, you will find we have some decimal here. So the way is we do the cell mass to get the nearest integer here. We will next have 10 groups. Each group will have the same size. See? Same size. Sometimes it's not exact same because we cannot give the perfect card. But they are almost the same. Because why is that? Because we have some, when we do the rank, if they have the same value, we have the same rank. You cannot say the same age to different place, right? Both of them 46, 64. You cannot say half of them go to the group 1, half of them go to the group 2. So that's the reason we still have some different cases here. But in general, they are what we like same size. Okay, that's the equal depth. If you want to official rules, you just go to some website. To the time reason, I skip this one. Just do the VLOOKUP for the range, like what we did for the equal width. The only difference is the cut point is by some rules or by this entry. In coding VLOOKUP. So I want to use VLOOKUP for now, but I think most of you guys know how to use VLOOKUP. I just use another way to do for the gender here. Encoding. Why we need encoding? Because in some software, we only takes the numeric data here, like 1 or 2, like you learn the SPSS, right? That software also gives you the option to encode some. We can just do that in Excel very easily with one function. We don't even need a function here. So first we need to make a plan for that. We have a male, female, and pending. And from data we know that the males are more than females. So males are the mode. So we can fill the missing value which is pending as male. So which means everything if it's not female should be male, right? We just do some student will say, okay, let's do if. You don't need if here. Just do, pardon me, the cell equal to double quote F, right? Just do this. It'll give you false and true, right? And but it's a boolean, not an integer. We want to convert that into integer 0 or 1. If that's the case, we just use the parentheses and times 1 or divided by 1. That's it. You will convert false to 0 and true to 1. There's some tricky here. Right. So now we get the nicely coded gender here. Right. So it's easier than if or VLOOKUP. You don't need a lookup table here. Okay. The feature engineering. Feature engineering, some students are asking me before the class, they said why we need that, because actually this is the most important part for the data analyst. So we want to create more feature from the data to give the computer more information about how to look at it, because computer is dumb. Many people say AI, okay, let's AlphaGo, but even for AlphaGo, it cannot do everything. It can only do some specific things in some area. If they can play the chess, they might not be able to drive a car. If you can drive a car, they cannot paint, right? For now, at least for now, AI is not means everything, and the different model must be used for different purpose. You cannot mix them together. You need to set up different model. Maybe you can install them into one machine someday, but for now, this one still very important. Is the beauty of the data analytics. You can create some feature. There's some explanation from Wikipedia. I don't want to read them. You can. The most important term is here, right? Brainstorming. And there's no standard way. Right? You need control this. Again, every time you need control. There's no right or wrong answer. Let's do first example here, the date. And the student can tell me what we can do with the date. Okay, the date has too many options here. So we want to make for this one is something like the beans, There's some kind of standard way for data analytics. Every time we say date, first the idea is change that to months, right? We can do year because we are all in the same year, but so we don't do year here. Months in Excel, it's just 2 months, and convert that data type into regular numbers without the decimal here. And now we can do day. Or which day? Today we can also do another card, like the beginning of the month or the end of the month, right? Or the middle. You can cut into 2 or 3 buckets, but here I just leave it here. You can do more. I just give some example. And another interesting thing is the weekday. I like this one very much, especially for business data. This one's not, but I still can show you how to do it. The weekday, 5, right? 5 weekdays. Monday, Tuesday. Remember the weekday starts from the Sunday rather than Monday. So 1 is the Sunday. Let's do another thing is we can do whether it's a weekend. Whether it's come from the weekend or from the regular workday, or some students may also add them to the holiday inside. But here we just do the weekend. If we can do if the weekday is 1 or 7, it's a weekend. Otherwise, it's 0, right? So we can do Either we can do if, but I don't like if. I like if, but I just want you to do if every time. We can do or, this one, equal to 1 or Q2 equal to 7. That's it. Right? First. 7 true. 1 true. If you don't trust me, you can look at this date to see whether it's a weekend, right? It's weekend. If you want that to be a integer, just times 1. You get 0 and 1. Okay, the dash, we have blank here. So first thing we want to field blank. Let's select this whole column. That's a trick here to select all the blanks. Right? Either you can filter on blank, then just type. Another way is you can use Control and G. Control and G go to, very easy to memorize, right? Go to Control and G, go to the special blanks. You select all blank cells and you type false in one cell and Control Enter. You get false. Let's check whether we filled more than what we want. Yes, we filled one more. So let's delete the last one. Sometimes it will fill the whole column. That's not what we want. So we should check that. Let's do dash code. Dash code. Right. Equal to true. Or we can just do this one equal to pick and true. Due to some reason that this true is not pure text, there's something hiding. So we just do equal to this cell, get it, and times 1. Or we can do 1 time. It's the same. Okay, we get 0 and 1s here. Okay, that's for the feature engineering. And some students may think this one is easy. Okay, I give you some hint here. Remember we have a province. So what other information we can generate from province? It's not from this data. Right, latitude and longitude. Right, we can convert the province to latitude and longitude. How? Let's go to the Google. Google is your best friend. So we can just search. Canada province latitude. I searched that before it's saved. So we can get, not all of them, but some of them. We need to do some adjustment for the name. I think it won't be hard. Right? For the US, I have some other ways, but for Canada, you still type. It's not much. And you get a latitude and longitude. Some people will ask why we do that. The information from latitude and longitude give you, especially the longitude. Sorry, especially the latitude. We want to get the latitude. If we get a latitude, we know the weather from that region, right? The higher latitude, if it's positive, high latitude, we will get the colder weather. If lower latitude, like 0 something, right, we get a hotter temperature or weather seasons in that case. This one is very important, especially you produce some product like air conditioner or clothes, right? Down jacket. Those information are very important. So you can convert this, just give you location, you get the latitude, longitude, right? Also, again, you can get another information about this, like population, right? The population for the province, which in this case would be very useful. If you search on the Canadian government open data, you can get the population, census population for this data set for the province. You can check. The more people they might have more chance to get the case. Also, we can calculate the ratio, right? If you know the population, if you know the number of cases, we can calculate the case ratio from here. So those are very important skill for data analytics. Now I think you know more about data analytics. It's much better than you just deal with the original data. The fetch operation gives you a very powerful way to look at data. The machine cannot do it. Even like a neural network cannot do it. If you just give the province for them, they are just characters. There's no background information for that. So for human being, we know much more about machine, about the data we have, right? So this is the information you can get. Okay, for time reason, I won't do the population here. Normalization. Normalization, especially for your data, is not in the same range. For example, some data has 1 to 10. Some data has 1 million to 2 million. If you put them together, the bigger number may capture the main trend for the data. You will give your biased information to your model. Some data can handle that, but some not. Some model can handle this problem, but some of them cannot, like regression especially. You cannot just put your data into regression, logistic regression for this model. If you do that, you will get a problem. But for this data, we only have one column, which is age. But still, you can use these simple formulas to transform them. There are more options, but those two are the most common ones. One is min-max. You use the distance between the value to the max divided by the full range. You get a number between 0 and 1. Or you can do the normal distribution, or we can call it z-score, to get the difference between the value and the mean divided by standard deviation. Normally, so within 6 sigmas, right? But the main body is between -3 to +3. Also, you can use this way to check whether we have outliers. And we also have the skewness fix, and we will mention that in SAS EM. Okay, we don't have much time, but we have to do this pivot table, right? Quick aggregation tool. You can play with this video 6 minutes to learn if you don't know how to use it, or you can follow me. Right, the benefit for this one is play with data to get ideas. Let's do that with the data. Now we have the data modified it. We can start from the province, or you can select all, right? But we don't use the first two. Let's select them all. Control Shift right down and insert pivot table. Creating a new worksheet. We just did that before. Now, firstly, let's look at the province and the number of cases. See the count. Right, we can see these numbers. The major is in Quebec, and then the Ontario or others. There's no pure places in Canada now. Last week we still have some places without COVID, but this one not. Let's do the age group as well. We can do either in the rows or in the columns. If we do this, we can do the ratio or the card count. You can see which age is the most, which is 40 to 59. is the most dangerous. And we also have greater than 100 have 3 cases. And we can also put if you put the death in here and remove the age, we can see the death. True is death, false is not death. And we can convert this number into percentage of the row, right? The death rate. The total 100 is how many people get this disease, and the ratio is the death rate. We can see the highest one is Quebec. Oh no, sorry, the Ontario. The following by Quebec and British Columbia. So we can see the difference here. The risk, one, if you unfortunately you get that case, the death rate, right? Some place is less, some place is higher. And we can also add the age group again to see the difference here, right? Or we can put that into a column, right? So here I give you a hint for here. It's very hard to see, right? It's hard to see from here. Actually, we don't need a false. We just need a true, because we care about the death rate. If you know the death rate, you know the no death rate. One thing is you can just make a filter from the death. Another way is you just remember we have the death code, which is 1 and 0. 1 is dead, 0 is not dead. It's a tricky one, and I like that one much. So let's, instead of remove the death, keep the province and age. Go to the death code here. This is sum because the false are zeros. Let's just use the average. The average is the death rate. Right, especially for binary. If you get binary data, this trick is very useful. Right now we get all the death rate here, and we can put conditional formatting here. Either you can use bars or you can use colors. Either way you like. Let's make a bar. The age group doesn't make sense to, oh, this is the equal depth. Let's make that equal with. So here, if you are greater than the greatest, the highest range is here. Here, 34%, and oh sorry, here, this range is young guys. Is young guys, but the problem here is we have very small number of the people who is less than 20 here, so we can look at the detail of why the death rate is here, half of them. And another case is 80 to 99. If I did another card, if you do that 90 to 99, the death rate is higher, it will become to 60%. So the way you do the binarization is also important here. And greater than 100 years, 1 out of 3. Right? You can see in the middle you're safe. If we just look at data, we don't care about the reason why this one. In the middle you're safe. In the lower part and higher part is safe. It's dangerous. Sorry. It makes sense to me because the senior people or the young guys might lack of the resistance to the disease. Let's look at the problem for the 0 to 19. We can just double click the 0 to 19 numbers total. Excel will generate the cases here, right? If a small number, it's not small here, but we have 100 cases for the young guys and 50 dead. So that's the problem here, right? So remember, I modified this data. Maybe it's not perfectly present the real case, but you can play with it. If you want to the real case research, you use the original data again. But I think for me, it's a good practice here. Okay. The last thing is the visualization. So there are a lot of visualization tools like Tableau and Power BI, but I just teach Excel in this class. That's a very powerful tool called 3D map. Insert. You can make a 3D map. It takes some time at first start. Okay. It is look like this. You just do nothing, it gives you Earth, right? You can make it flat map. That's the usual way we do it. And remember, it's 3D. You can see the bars. Something wrong here. City or province, that's wrong. We just want to do the province for now. Right? Each dot is a presence of province. And we want to add the height. Let's do the, which one? The desk here. Remember here the desk is not the actual desk. No matter you get true or false, you get desk. Right? We want to do the category for the desk as well. Right? True or false. You have different colors. And the last option, you have a time here. We can add a date. That's the only option here, date here. Let's make it bigger. Now you can run this play bar. You can see the time flies. At the beginning, we have Ontario and Quebec and BC, and everyone has it. Right? We cannot see that clearly, but let's use another type, because this one, compared with the deaths and the case, that's too small. Let's use 2 bars to do that again. See, at the beginning, no one died. Later, some deaths. See, and the case increase, deaths increase for each of those. Okay, just with the Excel, right? Think drag and drop. You get a beautiful visualization here, and I think you will get more if you practice more. Okay, that's the content for this section. I hope every one of you can have a time to practice with the data, and you will do this kind of exploration on the homework 1. Homework 1 is on Sakai. It's posted in the assignment section. It's bank e-payment adoption rate. You can use the similar way to do that. But more important than that, I didn't mention here, is the storytelling. Right? Actually, I should add one. So the storytelling. Right? Tell your story. Your story about your data. This one is very important. Practice with this. Many students said, I'm not good at presentation. You should do, especially as a data analyst. Right? if you can tell a good story about your data, you will win. We will talk about it later in the later chapters. But here I've introduced the tools. Remember, the tool is one thing, but the most important thing, whether you can find the story behind the data, right? Just like the problem I mentioned. It also the feature engineering is also important. If you can look at the data in a different way than others, and you have some good story to tell, you will be the winner in the market or in the business or even in the research, right? In the academic world. You still have something different than others. Why the famous people are famous, the successful people are successful? Because they use their story to explain the world. Okay, that's the thing I want to share with you guys. Okay, see you next week.